test soil using a vibrating table. Normally we have to find the Emax maximum void ratio and minimum void ratio of a free drainage cohesionless soil. Scope of the test. These test methods cover to determine the maximum index dry density or unit weight of cohesionless free draining soil using a vibrating table. The minimum index density unit weight represents the loosest condition of the cohesionless free draining soil that can be attained by standard laboratory procedure, which prevents bulking and minimum particle size segregation. Significance and use of the test. The density or unit weight of the cohesionless soil may be determined various in place method in the field or by the measurement of physical dimension and mass by laboratory of the soil specimen. The dry density of a cohesionless soil does not necessarily itself reveal whether the soil is loose or dense. Relative density or unit weight is expressed the degree of compactness of a cohesionless soil with respect to the loosest and densest condition as defined by the standard laboratory procedure. Here are some terminologies used in this test: dry density or unit weight. Dry density or unit weight of a soil deposit or fill at the given void ratio. Void ratio denoted by E. Maximum index density, minimum index void ratio, E max and E minimum, and then minimum index density and unit weight. These are the definitions provided according to the ASTM. Same as minimum index void ratio, E minimum, or relative density. Normally the relative density, the ratio expressed as a percentage of the difference between maximum index void ratio and any given void ratio of a cohesionless free draining soil to the difference between its maximum and minimum index void ratio. Here is an equation. On that basis we can find out the relative density. Here is another equation. DD, normally DD is denoted by the relative density. Here you can see DD or RD. These are the formulas or equations provided by the ASTM. By using these equations, we can find out the relative density. Density index or unit weight we can find out by these equations. Methods. There are various methods. Method A, B and C are provided by the ASTM, on which basis we can find out the maximum or minimum index density of a cohesionless free draining soil. Method A, in which using a funnel pouring device or a hand scoop to place the material in the mold. There is a funnel pouring device which will be used to pour a soil sample into a mold that will be placed on the vibrating table. Further we will discuss in the performance of the experiment. Method B, depositing material into the mold by extracting the soil filled tube. In this method we have to extract the soil specimen by a filled tube. And then method C, depositing material by inverting a graduated cylinder. In this we have a graduated cylinder in which we will measure the soil sample and then invert into the mold. The method to be used should be specified by the individual assigning the test. If no method is specified, the provision of method A shall govern. When we have to perform this test, we must have to mention the method on which basis we are performing this test. If no method is provided or described, then method A will be used or governed as a referee method. Method A is preferred, produced for determining the minimum index density or unit weight as used in conjunction with the procedure of test method ASTM D4253. ASTM D4253 also belongs to the maximum and minimum index density. Method B and C are provided for guidance of tests used in conjunction with special studies, especially where there is not enough material available to use a 0.100 feet cube or 0.50 feet cube mold as required by method A. These methods are applicable to the soil that may contain up to 15% of dry mass of soil particle passing number 200C, provided that they are cohessionless and free draining characteristics. Method A is applicable to the soil in which 100% dry mass of the soil particle passes a 75 mm or 3 inch sieve and which may contain up to 30% by dry mass of the soil particle retained on 37.5 mm or 1 and 1.5 inch sieve. On the other hand, method B is applicable to the soil in which 100% by dry mass of the soil particle pass a 3 by 4 inch or 19 mm sieve, where method C is applicable only to the fine and medium sands in which 100% by dry mass of the soil particles passing 9.5 or 3 by 8 inch sieve and which may contain up to 10% by dry mass of soil particle retained on number 10 or 2 mm sieve. These are the provision of the methods on which basis we can perform or select our soil specimen according to their percentage passing or required sieve. This is a relationship between dry density and void ratio. Here you can see if gamma D maximum dry density is equal to 0 and there is E void ratio will be infinity, as gamma D is minimum and E void ratio will be the maximum. This is a graphical representation of dry density void ratio and relative compaction. Operators used in this test will be standard mold having the diameter and height on which basis we can find out the area and volume, vibrating table, surcharge weight that is 25.4 kg, surcharge base plate, straight edge, weight balance and vernier caliper to measure the depth of the sample. Then procedure. First of all, mix the oven dry sample to provide an even distribution of the particle sizes. Perform a sieve analysis if required on the soil sample and find out the sample that has less than 10% passing through 200 sieve. Note the dimensions in which diameter and height of the mold in which the sample is to be poured and placed on the vibrating table. Pour the soil sample in the mold as loosely as possible. Fill the mold approximately 0.5 to 1 inch above the top of the mold with the help of funnel pouring device as described in method A. Screen off the excess soil by carefully trimming the soil surface with the straight edge without excessively distributing the soil surface. Determine the weight of soil and the mold. Obtain the weight of soil by subtracting the weight of empty mold. Determine the minimum density by dividing the weight of the soil with the volume of the mold determined earlier before performing or pouring the sample. Now place the mold on the shaking table and also place a weight on the top of the mold to provide proper compaction. Turn on the shaking table or vibrating table for a period of 5 to 8 minutes. Normally 5 to 8 minute period will be if according to ASTM frequency of the vibrating table is 80 Hz and if the frequency of vibrating table is 50 Hz then the shaking time will be 8 to 10 minutes. Turn the table off and place the vernier caliper on the top of the mold and note the depth of the soil in the mold from 3 directions and take its mean. H1, H2 and H3 will be taken and we have to take the mean value of these three at these three heights. Note the difference between initial and final heights. The new compacted volume is then calculated and maximum dry density is calculated from it. Then the relative density and relative compactions are calculated. Relative density can be calculated according to the following formula. Here is the formula: RD is equal to gamma D max divided by gamma dF multiplied by gamma dF minus gamma D minimum, gamma dx D max minus gamma D minimum. This is the formula on which basis we can find out the relative density. There are some observational calculations before the test. We have to calculate or measure the internal diameter of the mold. Height of the mold is equal to H1, weight of empty mold, weight of mold plus soil, weight of soil in the mold, volume of the mold, least count of the vernier caliper. Before test, vernier caliper reading at three different variations: D1 or H1, D2 or H2, D3 or H3. D average. On the basis of D1, D2 and D3, we will take the D average. Then we will calculate the compacted height of the sample. H dash is equal to H1 minus D average. Compacted volume of the sample V2 is equal to area of the mold multiplied by H dash, that is compacted volume. On this basis we can find out the gamma D minimum and gamma D maximum. Using this formula we have to calculate RD as discussed earlier and relative density. We can assume specific gravity or GS by 2.7, or we have to calculate the specific gravity of soil according to ASTM D857. Then E maximum is equal to GS multiplied by gamma W density of water divided by gamma D minimum minus 1. Then E minimum we have to calculate. Then RD relative density in terms of maximum and minimum void ratio. Here E max and E minimum, maximum and minimum void ratios, where EF void ratio in field, we can assume the void ratio and as well as we can calculate the void ratio by the field. So relative compaction RC is equal to gamma DF divided by gamma D maximum into 100. This is our relative compaction. This was the test for determination of the maximum dry density or maximum index density of a soil specimen, cohessionless free draining soil specimen. Now we will perform the experiment, and after performance we will see the results of the soil sample. Thank you. Now we will perform the practical performance of the maximum index density test, that is relative density, in which we will find out the E max maximum void ratio, E minimum void ratio, gamma D max maximum dry density and gamma D minimum, on which basis then we will calculate RC relative compaction and relative density. Apparatus used will be, that is funnel pouring device, mold, weight balance, straight edge, spatula, vernier caliper for the measurements, soil sample, scoop and another weight balance having least count 0.01 gram if required. First of all, we have to take the soil sample passing number 200 sieve, that is cohessionless soil or free draining soil. This is our required soil sample. After soil sample, we will take the mold and find out the area of the mold. For the area of the mold, first of all, we have to check the diameter of mold with the help of vernier caliper. The diameter of the mold is mentioned on the mold, that is 15.1 centimeter. Internal height of the mold, that is 15.5 centimeter, that is internal height. measured with the help of vernier caliper like this, we can find out the internal height of the or internal depth, that is 15 centimeter mentioned on the mold. Same as we can find out the internal diameter of mold with the help of vernier caliper. That is 10 centimeter, 15.1 centimeter. That you can see that like this we can measure the diameter of mold, that is 15.1 centimeter, and height, internal height of the mold. After measuring diameter and height, we can find out the area and volume of the mold. After calculating the volume of the mold, we have to place this soil in the mold with the help of method A, that is funnel pouring device according to ASTM. With the help of funnel, we will pour the soil sample into the mold. While pouring the soil sample into the mold, we must take care the dropping height of the sample by the tip of the funnel should be at least 1 inch. It should not be more than 1 inch because it can cause the self-compaction of the soil particles while pouring the soil sample into the mold. First of all, we have to place this our soil sample in this funnel, and after that we will pour the soil sample into the mold. Now we will fill this cone with the soil sample by the help of scoop and pour the sample in the cone. Like this way, we will fill the cone, as you can see that. You can see that the cone is filled up to the half. That soil is enough to fill the mold. Now we will lift the cone up to the height of 1 inch and fill the soil sample in the mold. Like that, we will fill the soil sample in a circular motion with the dropping height of 1 inch. In this way, we will fill our soil sample into the mold with minimum dropping height 1 inch, as you can see. As you can see that sample has been filled in the mold. The excess soil sample in the mold will be trimmed with the help of straight edge. Clean the edges of the mold and weigh the mold on the weight balance. That is our weight of loose soil filled in the mold, and its weight is about 8.048 kg. That is weight of loose sand and mold. After that, we will place this mold on a vibrating table, and further we will proceed on the vibrating table. This is our vibrating table on which we will fix the mold in these points with the help of screw, and then shake the vibrating table. Shaking period of the vibrating table is, if the frequency is 80 Hz, then the shaking period will be 6 to 8 minutes, maximum 10 minutes, and if the frequency is 80 Hz, then the shaking period will be 5 to 6 minutes. If the frequency is 50 Hz, then the shaking period will be 6 to 8 minutes, maximum 10 minutes. After fixing the mold on the vibrating table, first of all, we will place the surcharge base plate. That is our surcharge base plate. After that, we will place surcharge weight of 25 kg on the surcharge base plate. As you can see, surcharge base plate and surcharge weight of 25 kilogram. After placing, we will start the test with the help of this control unit, having the frequency set on 80 Hz so that the shaking period will be 5 minutes on by the stopwatch. This is the start of the test. You can see that soil is starting its compaction. This procedure will be followed for 5 minutes. After 5 minutes, we will take the readings. After 5 minutes, we will remove the surcharge weight and surcharge base plate. Now you can see that there is a decrease in the height of the sample that was filled in the mold up to the top of the mold. This decrease will be measured with the help of the vernier caliper or dial gauge. We will measure this decrease in the height by the help of the vernier caliper. We will take 3 readings at that point, second and third. At 3 different points, we will take the 3 different average value will be taken on the basis of these 3 readings. By the help of vernier caliper like that, we will measure the depth of the soil sample at 3 different points. First one is that, and after that we will measure the depth at second point, and then at third point. We can read the value on the vernier scale, that is on main scale and vernier scale, by the help of vernier caliper. These 3 values, first one was 3.1 centimeter, second one is 2.9 centimeter, and you can see that this is the third value on the main scale, 2.4 centimeter, and after that on the vernier scale, the graduation mark on the vernier scale will coincide the value of main scale. It is 1, as you can see here. 1 will be multiplied by the its least count 0.05, and these are our 3 values. On that basis, we can find out the compacted height of the soil specimen in the mold. On that basis, we will find out the gamma D maximum, maximum dry density and maximum void ratio. This was the performance of maximum and minimum index density test. Further, we will perform the calculation and then results.